Hi, so I'm going to present a quick summary of the paper Large Language Models Can Self-Improve. This was accepted to EMNLP 2023 and was written by Ms. Jiexin Huang during her time at Google. So the motivation. So we know that LMs have immersion capabilities. They can do in-context few-shot learning, which means that like they can learn to do new things that they have not been trained on, but by learning from the examples that we give them during prompting. And then with chain of thought prompting, they also show to have reasoning capabilities. But despite these immersion capabilities, to significantly improve the LM's performance, it still requires fine-tuning on a large, extensive label dataset. This will have limited application to low resource or specialized domains where obtaining label dataset will be difficult and expensive. So this paper tries to answer the research question, can LLMs self-improve with only unlabeled datasets? The short answer is yes, and here's the methodology. So we have the chain of thought datasets. So we use examples from that dataset to do few-shot prompting to encourage the language model to be able to reason and answer the question step by step. And so we will adjust the sampling temperature to make the model give our different reasoning paths. And we will sample like many different answers with many different reasoning paths and do a majority voting. So the answer that is most consistent, the answer that have like many reasoning paths leading to that answer will be selected. This is not necessarily the correct answer because we don't like refer to the gold label, right? But this will be the most consistent answer and will be the one that we will select. This is also called self-consistency. And so now that we have like the most consistent answer and the corresponding like different reasoning paths, we will have like many pairs of like the input and the output, which is the like reasoning path and answer. And so with these many pairs, we will also augment these pairs to have like mixed formats so that they have like different formats. So for instance, they have chain of thought example and then followed by the question. And then the corresponding output is like the chain of thought and the answer of that question. So that is one format, and another format that can be augmented is like just asking the question and then ask the model to think step by step. For the input and the output is like the chain of thought and the answer, or directly the answer. So like we will have like diverse formats of the same like original input and output. We will have like diverse format of it. The reason for that is that we would want the model to we would want the training example to not be biased towards like certain styles of answering, certain styles of input and output. So we will have a mixed format of selected reasoning paths, and we will use this like many augmented data to use to fine-tune the language model. So this language model that has been fine-tuned is called language model self-improved, because like we self-generate the sample data, the training data, and then we use that self-generated training data to fine-tune the model. So it's self-improved. So that's the methodology: chain of thought prompting, self-consistency, and then fine-tuning. Yeah. So the experiment they did is that they test on 3 different tasks: arithmetic reasoning, common sense reasoning, and natural language inference across 6 datasets. So 2 datasets for one task. And they use Google's Palm's 540 billion model to test. And they will prompt this language model with three different prompting style: standard prompting, chain of thought prompting, and self-consistency. And they test the performance before fine-tuning and after, like, doing the self-improvement fine-tuning. And so as we can see, the performance, they have like big gains in accuracy across all these tasks. Yes. And so this is like the performance for individual fine-tuning on each task. So we will have like many data sets of self-generated training example for each individual task like this. And then the next experiment that they did is that they will fine-tune on this all 6 self-generated training example to fine-tune the model on all 6 data, and then they will test on completely new task, new data set. So we can see that when testing on new out of domain tasks, there's also increase in performance after self-improvement as compared to before. Then in some cases where even like the training questions or the chain of thought examples you use as few shot prompting are limited, so like limited in domain training question and no in domain chain of thought examples, then what about that? So in that case, they will also try to self-generate the questions and self-generate the chain of thought prompts. And their experiments have shown that if they do self-improvement on the self-generated questions, then there's also improvement compared to like not fine-tuning anything at all. But of course, using the full training dataset is still give higher performance. And for their self-generating chain of thought prompts, they do less things step by step to have like chain of thought answers, and they show that few shot prompting with the self-generated step-by-step chain of thought examples outperforms a simple baseline of just using a simple listing step by step. They also experiment distillation to smaller models. So they will use the same set of training examples generated by the big model and use those training examples to fine-tune on smaller models. So here they experiment with models of size 8 billion and 62 billion parameters. And we can see that the distilled version here outperform the baseline significantly. And interestingly, the small model that has been fine-tuned using this distillation method outperforms the bigger model that has not been fine-tuned. For both the 8 billion that has been fine-tuned here outperform the 62 billion, and the 62 billion that has been fine-tuned outperform the 540 billion parameters model. So this is quite interesting. So in conclusion, the summary of this paper that yes, LLMs can self-improve the reasoning ability using only unlabeled questions. The method was chain of thought prompting, few shot chain of thought promptings with self-consistency, and then fine-tuning on those self-generated training samples. And it generalized like these improvements generalized to out of domain tasks as well, and can also have adaptation to low resource settings. And the distillation that like the reasoning knowledge that from the large models can be transferred and enhanced to the smaller models. So that's all for this very interesting paper from 2023. Thank you for listening.